Now comes the concept called as breadth first search. Breadth first search starts at the first vertex and tries to visit the vertices which are closer to the first vertex as possible. So in this essence or in this particular scenario, this search moves from a graph layer. So it goes layer wise. It goes to layer 1 first, which has n number of vertices, then layer 2, then layer 3 and so on. So first examining layers closer to the vertex, first vertex, and then moving down to the layers farthest away from the vertex. So it takes from the layer wise, that is why it is called as the breadth first search. So the basic algorithm for breadth first search, it uses a queue abstraction instead of an array abstraction for storing the visited vertices. The algorithm works in a typical manner like first visit the unvisited vertex that is adjacent to the current vertex. So this is my vertex A. Then I will look for the adjacent vertices which are nearer to A. Now there are 4 vertices, say K, H, E and B. So I will visit for these vertices first. So I'll go for K, then H, then E, then B. Now I visited these vertices, then I'll move to K. And then I can see there are nearby edges like L, I and many more things are there. So I will take L over here, then H will move to I, and then E will move to F, and B will move to C, and so on. The path can be decided as per your knowledge. But breadth first search takes a layer-wise kind of a polymorphism thing. It does not follow the depth first search where you have to visit each and every vertex which is not visited before. Here it keeps a logic that whichever is nearby, capture that area first and then move to the next area. So take the vertex V from the graph and add it to the list of visited vertices and all the unmarked vertices that are adjacent to V and add them to a queue. So this is a logic for breadth first search. So let's go to our code base where we will create an HTML file, and the logic for the breadth first search we will include that function because other logic like show graph and add edge is similar. So we will take that functionality from our previous code and we'll just add a new function, say BFS, that is breadth first search, and there we will include a logic to capture the nearby vertices. So let's go to our code base and create an HTML file and then the JS file. So this is my new file which will be created over here. It will be saved inside graphs folder as breadth first search.html. Now again this will have the typical doc type declarations, doc type HTML. Inside this I'll have the head tag, and before that we'll also declare the HTML tags. So we'll have the HTML tags, and the HTML tag will have the corresponding head tag and so on. So head tag will have the title. So my title is breadth first search. Breadth first search implementation. Now prior to that I will have the meta tag. So I'll have a meta char set as UTF-8. Now again I'll have the body tag. So inside the body tag I'll specify the h2 tag as breadth first search example. There I'll have the source inside the script. So it will be script src breadth first search, breadth first search.js. You can also specify the type over here. So it will be type text JavaScript. So it will be text JavaScript. So I've created my HTML file. Now I'll create this file, that is breadth first search.js, inside graphs folder. So here I'll create a new file and the name of the file will be breadth first search. So this will have some of the concepts over here like the way we had in our JS file. So this was my JS file. So I'll just take this complete part of graph because we are going to follow the same logic over here. But the only difference is that my function name would be BFS and other calling for the marked vertices will be with the same particular logic as the way we designed for depth first search algorithm. After this, I will just do the next function parameter. I'll just take them, that is add edge. So adding up an edge, showing up the values in the graphs are the same functionalities over here. So this was for add edge functionality like the way we did in our last chapter. Then comes show graph functionality. So this show graph would be in the same format. So I will take all these functionalities again over here because they are said to be common. Now comes the functionality of BFS. So let's create a function for BFS, that is breadth first search. So it will take the number of vertices. So I'll say function BFS V. Inside this I'll specify where Q. So I'm going to take it from the level wise. So I'll take a Q. So where Q is a blank array. This dot mark S equals true. Then comes, I'm going to push my values, whatever I have marked, means whatever I have visited nearby. So I'll say Q dot push. I'll mark the vertices over here, like add to the back of Q. After that, I'll take a while loop. So once I've completed with one level, so I'll do while Q dot length greater than 0. Then here I'll mark where I'll take a variable where V equals Q dot shift. It will take a shift parameter of a Q. So this will remove the entity or the item from front of the queue, which we pushed right now. And after this, I'll check if the vertex V equals undefined, then I'll print console.log the visited vertex as the particular value of the vertex. So I'll check if it is undefined, then I'll visit that particular vertex and it will be called as the vertex V. So I've done with this logic. Now next is to create a graph. So it will be G equals new graph, and the number of nodes inside the graph or the vertices is 5. Then I'll say G dot add edge 0, 1. Then comes G dot add edge 0, 2. After that comes G dot add edge 1, 3. Then comes G dot add edge 2, 4. So these are the number of edges which I am adding for my graph. Then I'll call for function show graph to show whatever the values are represented in it. And then I'll call for the first vertices. I'll start with my first vertex, which would be 0. So this would print P the value, the visited vertex. So it should go from 0 to the nearby values of 0 and the nearby values of the so-called numbers. So it should follow that particular logic. So let's go to our code base and analyze what we are getting the output over here. So this is the code representation and our file was breadth first search. So this was my breadth first search example. So the typical representation of the graph is given properly with respect to the nodes, that is the vertices and the edges. So which is present over here. So because we call for show graph function. Now the visited vertex. So it takes the visited vertex formula. So you can now clearly see the difference between the depth first as well as the breadth first. So here it goes level wise. So it calls for 0. The nearby element was 2. Then it called for 1 and afterward it went to 3 and 4. So this is a type like for depth first search we got 0, 1, 2, 3, 4. Whereas here we are getting 0, 2, 1, 3, 4. So this was a basic difference for analyzing breadth first search and depth first search algorithm, because Because breadth first search starts at a first vertex and tries to reach and visits the vertices which are close to the first vertex as possible. So in essence, this search moves through the graph layer by layer. So that was a basic difference between both of them. Now moving on to our next chapter would be a complete concept which is a part of a data structure called as the sorting algorithms and searching algorithms. So we will implement the sorting algorithms with the help of JavaScript with some basic use case and example. So let's start with our next chapter.